Okay. So this concept is okay. Where we stopped? This is okay. It is fine. And we move on. So this is how the two circles are coming. Okay. The blue circle is the value of load admittance, allowed load admittances at the point load LP2. The orange circle is the allowed load admittances at the point LP1. Is this okay? Is this okay? Right. So we can see if they are lambda by 8, what will be the angle? It will be 2 pi by lambda times lambda by 8. So lambda gets cancelled. That is pi by 4. This is pi by 4. Sorry, sorry. Sorry. Lambda by 2, right? This is lambda by 2 times. That will be pi by 2. This pi by 2. Because lambda by 2 rotation, we go one for one full. This is lambda by 2, not lambda. Okay. So this will be lambda by 2. That is pi by 2. So if it is lambda, this is lambda pi by 8, lambda by 8. The two circles will be tilted at an angle of 90 degrees or pi by 2. Is it okay? Is it okay? Right. Move on. Next slide. See, at lambda by 4, what will be the angle? 2 pi by lambda by 4 by 2 times sorry 2 pi by lambda by 2 pi by lambda by 2 times lambda by 4. So that is 4 pi by lambda times lambda by 4. So this gets cancelled, this gets cancelled. You get pi. This and this. Pi. Is it okay? Similar things happen. See, this is for 3 pi by, this is 3 pi by 2. Okay, can I explain this slide? What is meant by here? What is the problem? What happens at when it is lambda by 2, obviously it is the same circle, right? And why it is not a good choice, we will see later. Now see this one. Black circle like particles. Okay, which one? This one. This one I will explain when we do the mashing. When we do the actual mashing. This one you are talking about, this line. This line you are talking about. This we will explain when we do the actual mashing. Okay, we will do the actual mashing right after this. Maybe you understand. Now we had said that the disadvantage of the double stub mashing is that it cannot be used to match every possible value of load input. load admittance. Okay, why? See here. What happens if the value of admittance is on the blue inside the blue area? The value of all admittances which are in the sky blue area cannot be matched using double stub matching. Question is why? Can anyone tell why it is not possible to match any admittance which lie on the blue circle to be matched using double stub matching? Can anyone tell me what is the problem? Assuming that the admittance is here, this red dot, why cannot we match it? It is not possible to match it. Why? If we move D stub 2 to D stub 1, we cannot reach any point inside the blue circle. Ritika, first of all, is that we do not have to reach inside of this blue circle. We have to reach on the blue circle. Okay, we have to reach the points on the circle, not inside the circle. The first point. And second thing is that, see here, what we are doing for double stub matching. This is what we are doing. If this is my ZL, okay. This is LP1. We are putting our stub here, okay, and the stub is obviously inductive. Sorry, it is not inductive. The stub is always reactive. So, if we put a reactive stub, we will always move in the constant admittance circle. If we are putting a reactive stub, we will always move on the constant admittance circle, not on the constant resistance or any other circle. So, see here, if my admittance point at LP1 is here, okay, then we can move either here this way or this way. We cannot by any means reach the orange circle. Is it possible for us to reach the orange circle here by moving on to this circle? If we reach the orange circle, then we move again by the length d star 2 minus d star 1 to reach the blue circle, and we get a match by putting the second stub. But if we are in the blue area and we are applying a stub which is either an inductance or a capacitance, which is means if we move either this way or this way, is it possible for us to reach the orange circle in any way? No, right? That is the reason we cannot match any value of admittance which lie in the blue area. For anywhere else Smith chart, it is possible. Check. If the admittance lies anywhere else which is not on the blue area, it is possible by applying a stub to match it. Is it okay? See? And the second thing, as we move like this, the area is increased. See now? Because again, if we are in the blue region, it is not possible for us to reach the orange circle by adding a stub. Is it clear? Is it okay? See? Okay. Now let us try to match some impedances. Okay. Anyone give me a value of resistance? And anyone give me a value of an area resistance? What is the impedance you want me to match? The absolute value, not the. Okay. Give me an impedance, sorry, give me a value of impedance which you want me to match. Can you see the screen? 30 and 72. Okay, very good. 30 and 72. Okay. So, the normalized admittance is where? Here somewhere. Okay. This is the normalized admittance. Right? Is it possible to match this admittance using the double stub matching? First question is that. Is it at all possible? Yes or no? Do you think this admittance lies in the blue area or not? First question is it possible at all to match this admittance? Yes or no? If it is not possible, then there is no point trying. So it is out. So it is possible. Exactly, it is outside. So it is possible to match. So it is worth trying, right? So what we need to do? We have got two stubs. This one. This is the stub A and stub B. So what we need to do? We need to vary the length of stub A so that we can reach this circle. Okay. It will be very good if they are given the circles are two different colors. That doesn't matter. So what is the first step? We need to change this length so that we reach the yellow circle. Okay, let's do it. This is done. See that due to this length D0, this point is automatically matched on the blue circle. This circle. Okay. What is the second thing that is needed to be done? Simply vary this and we reach our goal. Change the value of this. Okay. Exactly. And our impedance is matched. The length of the two stubs is one is 0.37 lambda and the second one is 0.083 lambda. Okay. So to everyone, please do this. Take your own value of resistance, take your own value of reactance, try to match it. If you have any problem, tell me. I give you 10 minutes. Take your own value of resistance, take your own value of reactance, use this software and try to match it. If you are decayed, sure. The second step is varying this L stub to LB, this one, and to reach this center. Our goal is always to reach the exact center of this Smith chart. You can do it this way. See, I'm changing, and once we reach it, we stop. Yes, it is done. Okay. So all of you, please take your own value of R, take your own value of X and try to match it using this method. If you are having any problem, to report that values of R and X and I will try to match it. Okay. So I give you 3 minutes, you do it. Okay. Take your own value of R and X, I will not tell you, or do not take your own value. Try to match it. All of you have this software with you? All of you have the virtual lab? Great. So 10 minutes. Okay.